So in chapter 4.1, we're going to learn about inverse functions, and then we're going to relate inverse functions in chapters 4.2 and 4.3. So our objectives in this chapter are to identify one-to-one functions, to determine whether two functions are inverses, and find the inverse of a function. Definition of a one-to-one function. Our first objective is to identify a one-to-one function. A function f is one-to-one function for a and b in the domain of f if a does not equal b, then f of a does not equal f of b. Equivalently, if f of a equals f of b, then a equals b. So in example 1, we want to determine if the relationship defines y as one-to-one function of x. To do this, we see ordered pairs, and we will write out the ordered pairs. So we have 2, 1, we have 4, 2, we have 7, 3, and negative 2, 1. In this particular case, y is not one-to-one because for two values, different values of x, we have the same value of y. So this function is not one-to-one. In example 2, we have the relationship of x to y, and now we see that for Batman, the name Blaine comes up. For Green Lantern, Sistero comes up, and finally, for Wolverine, Juggernaut comes up. Likewise, it can go in the opposite direction. Juggernaut goes to Wolverine, Sinestro goes to Green Lantern, and Blaine goes to Batman. So it's a one-to-one correspondence for each person going to one individual's name. So to determine whether or not we have a one-to-one function graphically, we do what's called a horizontal test. So a function defined by y is equal to f of x is one-to-one if no horizontal line intersects the graph more than one point. So in example 3, we will create a following function. F of x is equal to x cubed. In this case, we have an idea that this function at 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. So this thing will go up like this, and it will go down like this. So now we're going to take a look and see if we can create, if we go and do a horizontal test at various points, and if we cross the function at only one point, we have a one-to-one function. And in this case, f of x equals x cubed is 1-to-1. So in examples 4 and 5, we want to determine if the relation defines y as a one-to-one function of x. Again, we'll apply the horizontal test. When we do that, when we draw a green line through our particular value here, we see that we cross this particular function at multiple points along the horizontal. This is not one-to-one. But now if we look at the other function, we'll draw it with red, we can see, in fact, we have 1 to 1. So example 4 is not 1 to 1, but example 5 is 1 to 1. In skill practice 2, use the horizontal line test to determine if the graph defines y as 1-to-1 function of x. Well, when we look at A, we draw the horizontal. And we see that in fact we cross the function at 2 points along the horizontal line, and so therefore this is not 1 to 1. Let's look at B. Well, we go across and we see that in fact we do get only 1 point along the horizontal. However, this function, this is not a function in the first place. Why? Because a function meets the vertical line test, and this function is not a function. Because it's not a function, we don't perform a horizontal test. Then we do the last one. And sure enough, this meets the vertical line or the horizontal line test, and of course the vertical line test. So this function is 1 to 1. Now we're going to use the definition of 1-to-1 function to determine whether a function is 1 to 1. We're going to show that if f of a equals f of b, then a equals b. So for example, suppose I evaluate example 6 in the following fashion. Suppose I say I evaluate f of 1, and when we do that, we get 3 times 1 plus 2, which is equal to 5. Now, we ask ourselves, okay, suppose I reverse the operation. Suppose I have 5, and now we have 3x plus 2. Solve for x. And what do we get for x, right? So we subtract 2 from each side. We get 3 is equal to 3x. And this implies that x is equal to 1. So in fact, we evaluated at 1 and we got 5. And we put 5 for f of x, and we got x is equal to 1. This is 1 to 1. Now we're going to do the next function. Suppose we again try f of 1 is equal to 3 times 1 squared. This means that f of 1 is equal to 3. Well, now we're going to do the reverse. We're going to let 3 is equal to 3x squared. Now, we divide both sides by 3, and we get 1 is equal to x squared. But we have x squared. We take the square root of both sides. We get the square root of plus or minus 1 is equal to x. This means that x is equal to 1 or x is equal to minus 1. There's our problem. This is not 1 to 1 because we get two answers for 3, whereas when we first evaluate f of x of 1, we get just 3. So this is not 1, 2, 1. Now I would like you to try. I would like you to do skill practice 3 and determine whether the function is 1-to-1 or not. And so go ahead and pause and do both A and B. So in both cases, you can see the values. For A, when we did it, we substituted f of 1, for example. It could have been f of 2 or f of 3. And when we did the function, we ended up finding that x1 is the same as what we evaluated the function for. So we had a 1-to-1 function. For part B, again, we put in f of 1 is equal to absolute value of 1 minus 3, which is f of 1 is equal to a negative 2. And then, of course, what we did is we let the function be negative 2, and we said, okay, solve for x. We added 3 to both sides. We got 1 is equal to the absolute value of x, but now the absolute value of x inside can either be positive or negative. So in this case, x could either be 1 or x could be negative 1. And we see that this is not a 1-to-1 function. Our second objective is the definition of an inverse function. Let f of x be 1-to-1 function. Then g is the inverse of f if the following conditions are true. If f composite g of x equals x for all x in the domain of g, and 2, if g composite of f of x equals x for all of x in the domain of f. We should also note that g is the inverse of f, then f is the inverse of g. Furthermore, given the function f, we often denote its inverse as f raised to the minus 1 power. Given that a function f and its inverse f to the minus 1 is the definition that implies that f of the composite of the inverse function is just equal to x. So now we want to determine whether two functions are inverse functions of each other. So the way we're going to do this is we're going to look at f composite of g of x, and this is going to give me 3 parentheses 1/3 x minus 2 plus 6. When we solve this, when we distribute the 3, we get x minus 6 plus 6. And let me make sure I get this right. So let's go back and get this to be 6. This just equals x. So by definition, f of x, or g of x, is equal to f of x to the minus 1. So it is an inverse function. Yes, is the answer. Now I'd like you to try the same thing for example 9. Go ahead and see if in fact we have an inverse function. Go ahead and pause and try it on your own. So now you can see we did fog of x And when we did the composite, we put g of x in for x for the function f of x. And when we see we did that here, and then we solved, we did some manipulation. We added the ones together. We get 5x plus 2 over 5. We can divide 5. And we get x plus 5 over 2, which is not equal to x. So this is not an inverse function, right? No inverse here, right? Between f of x and g of x. So in skill practice 4, we're doing an application of an inverse function. The cost to rent a kayak at a beach resort is a flat fee of $10 plus $5 per hour. The cost f of x in dollars is given by f of x is equal to 10 plus 5x, where x is the number of hours that the kayak is rented. B says determine if the function defined by g of x, x minus 10 over 5, is an inverse function of f. And then, in part B, interpret the meaning of g of x in the context of this problem. So in our first example, we are going to do part A, and we'll do fog of x. And when we do that, we get 10 plus 5, parentheses x minus 10 over 5. We see that the 5's cancel, and we're just left with 10 plus x minus 10. The 10's cancel, and we get x. So in fact, we have an inverse function, and g of x is equal to f of x inverse, right? So part B is, what is the meaning of the context? Well, if we're renting, if f of x is renting, then g of x is getting our money back for not renting. So g of x, in the context of the problem, is we paid the money, for x hours, but we didn't rent. So this is getting our money back. Right. Objective 3 is the procedure to find an equation of an inverse of a function. For a one-to-one function defined by y is equal to f of x, the equation of the inverse can be found as following. Step 1 is replace f of x by y. Step 2 is interchange x and y. Step 3 is to solve for y. Step 4 is to replace y by f to the minus 1 of x. Step 5 is find the domain and range of the inverse function, which is, in fact, the domain of the inverse function is the range of the original function. The range of the inverse function is the domain of the original function. So we're going to try our first function. We will go ahead and do that. In this case, we're going to let f of x equal 5x plus 2. Now, the first objective was to do what? We now let y, hold on just a second, x is equal to 5y plus 2, right? Because then we interchanged x and y. And now we solve for y. So now we're going to get x minus 2 is equal to 5y, which means that x minus 2 over 5 is equal to y. And so now this is our inverse function, so we can write it as f to the minus 1 is equal to x minus 2 over 5. Here's example 10. A one-to-one function is given. Write the equation for the inverse function. So in this particular case, we originally have y is equal to 2 plus 1/2 x, and now we're going to interchange x and y. So now we have x is equal to 2 plus 1/2 y, and we're going to solve for y. So we get x minus 2 is equal to 1/2 y, and so now we get 2x minus 4 is equal to y. So here is our inverse function. So f of x to the minus 1 is equal to 2x minus 4. And we can graph that particular function. At minus 4, we are here. 1, 2, 3, 4. That's our y-intercept. And now we go up 2 and over 1. We go up 2 and over 1. And so guess what? Here is our inverse function. Looks like. Okay. Now we would like you to do a practice. So skill practice 5, write the equation for the inverse function for f of x is equal to 4x plus 3. Please pause the video and try this, and we will show you what the results are. So here is the solution for our skill practice 5. We start out with the original equation, and we then let f of x equal y. So we have y is equal to 4x plus 3. We interchange x and y, and now we solve for y. So as we solve for y, we get that y is equal to x minus 3 over 4. That is our inverse function. And so we write our inverse function in the following fashion. F raised to the minus 1 of x is equal to x minus 3 over 4. So that's our inverse function. Here we're going to start out with y is equal to 3x over x plus 1. Now we're going to interchange x and y, so we have x is equal to 3y over y plus 1. Now we're going to multiply both sides of the equation by y plus 1. We get x times y plus 1 is equal to 3y. Now we're going to distribute the x. We get x, y plus x is equal to 3y. Now, we're going to get the y's together. So we're going to let this be x, and we're going to bring the xy over, and we're going to get 3y minus xy, right? We can do that. We can bring the xy. And now I'm going to take a y out of both of these terms. So now I get x is equal to 3 minus x in parentheses times y. Now I can solve for y, right? Because y is just equal to x over 3 minus x. Notice that here our domain, or our domain here for this inverse function, is that x cannot equal 3, right? And guess what? We have a horizontal asymptote, right, for the range value for 3 from the original equation, right? So over here, right, the domain, right, was negative infinity, right, to negative 1, union 1 to infinity, right? Negative 1 to infinity, that is. But now the domain of the inverse function is, right, the domain of the inverse function is negative infinity comma 3 to union 3 comma infinity, right? So notice that the inverse function now has a domain of the range of the original function, and it turns out that the inverse function has a range of the domain of the original function. Okay, so it's your turn. Skill practice 6. Write an equation for the inverse function for the one-to-one function defined by f of x is equal to x minus 2 over x plus 2. So go ahead and pause, try your luck, and we will show you how this works. So here's our solution. It looks a little complicated, but it's not. We start out with y is equal to x minus 2 over x plus 2. Then we interchange x and y, and we get x is equal to y minus 2 over y plus 2. Now we multiply through by y plus 2, and we get x parentheses y plus 2 is equal to y minus 2. We distribute the x, that's our next step right here. So x times y plus 2x is equal to y minus 2. We're going to bring the 2x over to the other side of the equation, so we get xy is equal to y minus 2 minus 2x. And now we're going to bring the y over to the other side, so we get x y minus y is equal to a negative parentheses 2 plus 2x. I just took the negative out of both the 2 and the 2x. Now I can take out the y from both terms on the left-hand side, and we get y parentheses x minus 1 is equal to a negative 2 plus 2x. And now I can divide both sides of the equation by x minus 1, and that gives us the inverse function right there. And we can see that the domain of the inverse function is negative infinity to 1, union 1 to infinity. So in example 12, we have a one-to-one function as given, but we automatically have a domain in this particular case because the original function f of x equals x squared plus 3 is not one-to-one for all x. So it's only one-to-one for x greater than 0 in this particular case. I could split up the parabola in two different ways. So in this case, I'm going to go ahead and allow myself to look at only the positive options for x. And so now I'm going to let y is equal to x squared plus 3. And now I'm going to interchange x and y. So I have x is equal to y squared plus 3. And now I've already made sure that x is only positive. So now I can have x minus 3 is equal to y squared. Now, I take the square root of both sides, and you'll notice that I have a negative and a positive value. However, because x is defined for only those positive values, right, so I only get the positive x minus 3 is equal to y. And the reason for that is because I have made the fact that x is only positive at the original domain. X is only positive. It's not a negative number. So because of that, then when I take the square root, I only get the positive square root of this inverse function. So the inverse function here, in this particular case, is equal to the square root of x minus 3. Now, interestingly enough, we can start taking a look at where x now is defined. Well, in this particular case, the domain starts at 3. So we come over 3. And when we're at 4, we're here. And when we're at 7, we are at 2. Right? So this function looks like this. And so here is the inverse function for the original function. And the domain in this case, right, is 3 to infinity, right? So there's where it's at there. Okay? Alrighty. So now we'll go to the next problem. So I'd like you to go ahead and look at skill practice 7, and it's given n of x is equal to x squared plus 1 for x less than or equal to 0. Write an equation of the inverse. Now again, x can be divided up into two pieces. As long as it's not for all of x, then I have a one-to-one function for n of x. So go ahead and find the inverse of this particular equation, and we'll show you how this works. So in this case, we notice that the domain for x is less than 0. So we've drawn a picture here, over here, of what the function looks like. So now we interchange both the x and the y, And now x is equal to y squared plus 1. And now x minus 1 is equal to y squared. And now, because we take the square root of both sides, now we have a negative of the square root of x minus 1. The reason for that is because the domain for the original function is less than 0, which is negative. So on the left-hand side it's going to be a negative. So now we have the inverse function is a negative square root x minus 1 when we graph it. And there's our graph. The black is the original function, and then the red is the new inverse function. So now we're going to try to do skill practice 8. Here we have g of x is equal to the square root of 2 and find the equation of the inverse. So in this particular case we have y is equal to the positive square root of x plus 2. So we know what the domain is. The domain is, it can be negative 2 to infinity, right? And we also know the range. The range is going from 0 to infinity. So, now we'll interchange x and y. So x is equal to the square root of y plus 2. We square both sides. We get x squared is equal to y plus 2. And now we have x squared minus 2 is equal to y. Now, this function is defined only in the following way. Its domain is going to only be from 0 to infinity. That's the domain. And the reason for that, in other words, x is greater than or equal to 0, right? So this function is only defined on one side of 0, right? So f of x minus 1 is equal to x squared minus 2. And it's only defined for that domain, right? And its range is from negative 2 to infinity, right? Notice how the range and domains flip for the inverse function. Our final idea here is to notice something about the graph of the function and the inverse function. And we know that through the equation y equals x, that a mirror image of the inverse function of the original function passes through exactly through the line y is equal to x. So in this case, the mirror image for this particular function is going to start out here. So there's going to be a point here. The next function is going to have a point right here. And then this function is going to have a point right here. And then finally this one is going to be right here. So our inverse function is going to look like the same idea that is mapped through x equals y. So there it is. There's our inverse function. That concludes our chapter 4.1 on inverses, and we'll be discussing more of that in class.